This video is about solving logarithmic equations. The property of equality for logarithmic equations states that equivalent logs that have the same base are going to have equivalent arguments. So if there's an equal sign between two logs and both of those logs have the same base, then we can say that their arguments are equivalent as well. So the argument of the first log here is just x. The argument of the second one is 7. Therefore, x equals 7. And that's kind of common sense. If you have log base 2 of x equals log base 2 of 7, well then x must be 7. We're going to use this in slightly more complicated problems, like this one. We're going to solve this log equation. Because it's an equal sign between two logs and the logs have the same base, I can say that the argument on the left, which is 4x minus 7, equals the argument on the right, which is x plus 5. And then I'm going to solve the resulting equation, which here is just a linear equation. Subtract x from both sides, so 3x, add 7 to both sides, 12, and x equals 4. I can check my answer. If I plug that 4 back in, I would see that the left side does equal the right side. However, you're not always just going to have a log equaling another log. You may have a log on one side and just a number on the other, in which case you want to use a process called exponentiating to solve the log equation. I'm going to explain this as if we're just going to switch it to exponential form, though there is another possibility to think about it as exponentiating on both sides. I'll show both ways in class. But for this case, I want to just write this log in exponential form, which is something you should have practiced doing a lot. A log is just another way of writing an exponential equation. So we have a log that's base 4, which means when I write this as an exponential equation, the base is going to be a 4. In a log equation, remember that what's on the other side of the equal sign is the exponent. So this is 4 to the third power. And it equals the argument of the log. And the whole thing in parentheses here is the argument of the log, 5x minus 1. To solve this equation, actually do 4 to the third power. 4 times 4 times 4, 64. And then solve it. It's a nice linear equation. 65 equals 5x. And then we want to divide by 5 on both sides, and x equals 13. It is important when doing log equations to check for extraneous solutions, mostly because you can't do the log of a number less than 1, of a number that's 0 or a number that's negative. So when you plug your answer back in, you want to be careful that you're not doing the log of a negative number, because that answer would be extraneous. So let's see how we're going to do a problem like this. This is slightly more complicated. We have 2 logs on the left side, and it equals a number. I'm not going to be able to just move one of these logs to the other side and use the first skill, because there's this positive 2 right here. That would just be stuck there. So what I want to do instead is take the 2 logs that I have on the left and combine them to a single logarithm. We practiced combining logs and writing them as a single log. And remember that when there's a plus sign between 2 logs, you can combine it as a single log with multiplication. You take the argument of the first log, which is 2x, and it's getting multiplied by the argument of the second log, which is x minus 5. So to combine 2 logs with a plus sign between them, you multiply their arguments. So we've got the log of 2x times x is 2x squared, and 2x times minus 5 is minus 10x. And that equals 2. I'm now going to exponentiate, or write this in exponential form. The base of a log, when the base is not shown, is 10. The exponent is the thing that's by itself on the other side of the equal sign, which is a 2. And it equals the argument of the log. All right, so for the first time, we've gotten rid of the log, and now we have a quadratic equation. You may get 2 answers here. So I'm going to simplify this and get everything to the left side. I know 10 squared is 100, and so I'm going to subtract it from the other side. So it'll be 2x squared minus 10x minus the 100 equals 0. I'm going to factor it and use factoring to solve this if I can. I see that I can take out a 2, leaving me with x squared minus 5x minus 50 equals 0. Factor what's in here. I can use x minus 10 and x plus 5. And then using the zero product property, x equals 10 and x equals negative 5. Now I want to go back to my original equation and check if these both work in the original equation in case one of them is extraneous. So going back to the original equation where the logs were separate, it's very important that you go back to this one. When you plug in a positive 10, this ends up being the log of 20, and this ends up being the log of, well, 10 minus 5 is 5. The log of 20 plus the log of 5 is like saying the log of 100, because we know we can combine two logs together by multiplying their arguments. And does the log of 100 equal 2? Well, check. Does the base of 10 raised to the second power equal 100? And sure enough, it does. Therefore, positive 10 is one of the answers to this. You can put a box around it or a check next to it, indicate that that's one of the answers. When I check negative 5, plug it into the original equation, this ends up being the log of negative 10. Already I have to stop and know this got to be extraneous. I can't do the log of a negative number. Base 10 to no power will ever give us negative 10. And therefore, negative 5 is an extraneous solution. Cross it out or write extraneous so you know it is not one of the solutions. Now that doesn't mean that every time a negative answer is not going to work. It just means if you plug it back in and obtain a negative inside your log, that's when it doesn't work. So you got to be careful to always check both positive and negative answers. One more example. We've got two logs. We're going to combine them into a single log. Log base 4. Multiply the arguments because it's a plus sign in between them. So x squared plus 12x, and it equals 3. Exponentiate, or write it in exponential form. It's base 4 to the third power equals the argument of the log. Get everything on one side. In fact, let's multiply. 4 to the third power is 64. Use factoring to solve if possible. It's what multiplies to make 64 that adds up to 12. Minus, let's say, plus 16 and minus 4. So the solutions would be negative 16 and positive 4. And then plug them up back into the original equation and see which ones work, or sometimes both of them will work, sometimes neither. If we plug in our positive 4 is going to work out just fine. And when you plug in negative 16, you'll see that negative 16 plus 12 gives us the log of a negative number. And so therefore, the negative 16 is an extraneous solution. And that is all.